Bismillahirrahmanirrahim. Assalamu alaikum. Let's begin with the third part of our chapter Fats and Oils in Food Products. Functional roles of fats. Color. As we all know that fats gives color to the food. Butter contributes a yellow to creamy color to products, and the importance of this pleasing color is evidenced by the fact that all margarines are colored to stimulate the color of butter. Even some vegetable shortenings now have beta-carotene added to provide the desired yellow color. And it has also been witnessed that most of the vegetable oils are colored specially, and they are not kept white or transparent in color due to the same reason. Fats also aid in developing a pleasing color on the surface of fried and baked products. We can see this example nowadays as we are making a lot of pakoras and rolls and samosas these days. If the same product is air fried or they may be baked without oil, the color remains white. While if the same product is cooked in oil while deep frying, it gives a good, pleasing golden brown color. Flavor. Fats contribute a richness of flavor when used in a variety of food products. Specific fats provide unique flavor qualities. For example, butter has a complex flavor profile contributed by butyric and other fatty acids. Butter itself does have a very distinctive flavor, and when it is added in specifically in baked products, it gives a very good flavor of profile. The flavor of butter is so popular that most margarines and some shortenings have synthetic butter flavorings that are added to them to stimulate the natural flavor of butter. Though they are not butter, but the commercial companies make possible ways to compare the flavor of butter with margarine. Olive oil and lard are examples of other types of fats that contain distinctive flavor components. We have all tried olive oil. You all must have tried olive oil when the food is cooked in olive oil, or if we use olive oil in our dressings, it gives a very distinctive flavor. Texture. Fat does influence the textural characteristics in several different ways, depending on the type of food considered. In pastry, the distribution of fats in small pieces contributes flakiness to the baked products. Butter or shortenings can be creamed with sugar to obtain a very fine silk structure of great uniformity in a shortened cake. The shortened cakes are like impossible to make without the cream, without making the cream of sugar and butter, because it is the main, you can say, ingredient that gives very fine cell texture to the cake. Fats in a bread dough keeps the crumbs and crust soft in comparison with a similar bread made without any fat. And experiment I have done experiment over it by making bread with and without fat, or you can say the less amount of fat than it is required. There is a huge difference between them. Then I realized that fat does plays a very important role in its textural quality. Fried foods develop a crisp textures on their surfaces, the result of being heated at very high temperature that can be reached when fats or oils are the cooking medium. For example, hash browns and French fries, and we have so many local foods. We can witness the example. Um, there are so many local foods. If the fat is too cold, the result, unfortunately, is a soggy, greasy texture. Why? Because low temperature always tend to get absorbed in food as compared to the high temperature. Tenderness. One of the most important qualities is the ability of a fat to aid in creating a tender baked product. How it has happened? The ability of various type of fats oils to tenderize a product is determined by their ability to interfere with the development of gluten, which is a structural protein which is formed by the combination of water and wheat flour. When they both are combined and manipulated, they may be beaten together, it forms a gluten. For the development of gluten, these two ingredients are required, and it creates a structure that is stretchy. What does the fat do? It actually stops this inter reaction with each other. Lipid forms a protective layer around the flour and it stops the development of gluten, and this gives a product that is more tender. So the ability of a fat to cover a large surface area to minimize the contact between the water and gluten, I just have explained, is known as the shortening power. Rigorous blending of fat and sugar to incorporate air to promote fine light texture in cakes is known as creaming. This creaming process is frequently seen in making of shortened cakes. For creaming to be effective, the fat needs to be able to retain the air pockets that form. Butter and margarines also can be creamed, but with more difficulty than is encountered in creaming shortenings. Margarines has a broader temperature range of plasticity than does butter because of the varied fatty acid content. What is meant by plasticity? It is an ability to get incorporated and so that it can be spread easily. The other ability that it can be spread easily. So this makes it easier to cream margarines than butter without causing the fat to become so fluid that the emulsion in the batter breaks during later mixing. It is always recommended to have those kind of fat in creaming that has an ability to get in the air and becomes light. Flakiness is the quality of thin layers of pastry that shatter when cut or chewed. It is highly desirable characteristics in pastry. When fat is left in pieces in a pastry dough, what happens? It gets melted during the baking period and flows, leaving a hole where steam collects and pushes upward against the upper surface of the resulting cells. So that is why pastry is always looks so tempting and tasty because it has a solid fat in it that gets melting during baking. Biscuits utilize a hard fat that can be cut into small pieces in a fashion similar to preparation of pastry. This promotes flakiness in biscuits. In muffins and yeast breads, the fat is melted to obtain maximum tenderizing. All food systems have an aqueous liquid of some type in their formula, and many also contain fats and oils. The result is that these ingredients may be uniformly dispersed as an emulsion or curded. So this is known as emulsification. In food systems, the type of emulsion formed is an oil in water emulsion in which the oil droplets are dispersed in aqueous phase. An emulsifying agent of some type may be needed to facilitate the formation of stable emulsions. In textured cake that gives a good texture, shortenings are formulated, and they are formulated with some added mono and diglycerides. They are known to be as an effective emulsifier so that the fat and milk in cake batters are emulsified. Other example is the mayonnaise, and in mayonnaise the emulsifier which we use is lecithin, which is present in egg yolk. Lecithin is a phospholipid that is unusually effective in covering the surface of droplets in an emulsion to keep them from coalescing. Fat replacements. Basically, fat replacements are used in place of the actual fat so that it can give the same textural qualities to the food without adding large number of calories. So various approaches to developing ranges include protein-based replacement, carbohydrate-based replacement, and fat-based replacements. Protein-based replacements are made by modifying proteins using egg white or whey from milk. Examples include whey proteins and microparticulated egg white and milk protein, such as Simplis. Simplis is a multifunctional dairy ingredient which is used as a fat substitute in low-calorie foods. The protein is partially coagulated by heat, so creating a micro dispersion, which process is known as microparticulation, is done in Simplis to give the good texture to the food. Simplis is digested as a protein, but due to the microdispersion form, it produces only 1.0 to 1.3 calories per gram as opposed to 9 calorie per gram that produces regular fat. It is used in ice cream, yogurt, cheese spreads, salad dressings, margarine, mayonnaise, coffee creamer, soups, and sauces. Carbohydrate-based replacement such as starches and gums, they may have unique properties that gives the textural properties of fat to the food. Carbohydrate-based substitutes are used to replace the fats in baked products, cake and cookie mixes, dairy products, frostings, frozen desserts, and salad dressings. Here are some carbohydrate-based fat replacement: Enlight, Stiller, Splendid, Atrium, Absol, polydextrose, and Bacillate. They all are meant to be used as a fat replacement, but they are derived from different sources and they may be used in different food products which are already mentioned over here. You can see the details. Enlight is based on starch and containing other natural food materials including gums and non-fat dried milk. Stellar is a product made from cornstarch. Presently, it is used in cheese, spread, and frosting. Splendid is a fat substitute made by Hercules. Is based on carbohydrate as pectin. Atrium is a fat substitute made from oat. When we heat atrium, form gel and it provides less than 1 calorie per gram. The uses of atrium includes milk containing beverages, salt dressings, made cheese spreads, and high fiber spreads. Absol is a microcrystalline cellulose gel, which is a gel network formed by carbohydrate derivative. Polydextrose is a complex carbohydrate made from glucose, citric acid, and sorbitol. Parsley is a potato starch maltodextrin used in dips, bakery products, dressing, ice creams, and fillings. Fat-based replacements. In these fat-based replacements, they are made by replacing triglycerides in vegetable oils. Examples include caprenin, celetrim, and olestra. Caprenin is poorly absorbed fat, which contains two medium-chain fatty acids and one very long-chain fatty acid that is esterified to glycerol used as a fat replacer. While celetrim is a acronym for short and long chain acyl triglyceride molecule. Body utilizes celetrim that contributes about 5 kilocalorie per gram. Olestra is a part fatty acids from cottonseed or soybean oils and part sucrose rather than glycerol in triglycerides.